So what we're going to do right now is we're going to try a couple of examples of trying to figure out how the speed of sound affects frequency and wavelength. And to do this example is not in your notes, but I would like you to have a piece of scrap paper out, and you can pause the video if you need to. But grab a piece of scrap paper and follow these next two examples. After you do that, your Microsoft Forms checkout questions that are in the assignment that you first took a look at are going to be just like these two examples. So you're going to want to write this down so that way you can practice it, so when you go try to do it at the forms at the end, that you have this information. So let's take a look at this example. What I want to know is what is the wavelength of a 440 hertz sound wave in air at STP. Now we know a couple things. The frequency has been given to us, 440 hertz. And I also tell you that the air is at STP. That means that the velocity of the air, or the velocity of the sound wave in air, is going to be 331 meters per second. I'm trying to find wavelength, and those three variables, velocity, wavelength, and frequency, are all related by our wave equation, which is velocity equals frequency times wavelength. So plugging in those values, we can plug in for velocity, 331 meters per second, and frequency, 440 hertz, and then all we're solving for is our unknown variable, which is wavelength. And if we take 331 and divide it by 440, we end up with a wavelength of 0.75 meters. So this is an example of how you would take wavelength of a sound wave moving at STP and be able to find frequency. Let's just try one more example of this, and we're going to take it the other way. In this scenario, we're going to start with wavelength and find frequency, whereas before we started with frequency and we found wavelength. So here we want to know what is the frequency of a sound wave with a wavelength of 1.5 meters. Again, we're going to apply to the same exact equation. Velocity equals frequency times wavelength. Plugging in for what we know, and the velocity, since the air is at STP, the velocity of sound in that air is going to be 331 meters per second. We can set up this expression. 331 meters per second, that's our velocity, is equal to frequency times 1.5 meters. And if we divide 331 by 1.5, we're left with frequency, and that tells us that our frequency is going to be 220 hertz. Now, your questions in your checkout questions inside your Microsoft Forms that this assignment was associated with are just like these two sound examples. There are more slides that we're going to go through that are going to talk more about pitch and loudness, but I want you right now, or I would suggest that you right now, just pause right now in your Nearpod and go back to the forums and try these examples, because those are going to be what I'm going to ask you at the end. When you're set with those, just watch these last couple of slides where I talk about loudness and pitch and kind of relate it to some other terms that we're more familiar with when we talk about sound and hearing.